Stacy showed me my napkin. I saved the napkin and went to wash
Really?
Dude, what is happening?
Hey, sweetheart, can you pay me?
Yo, this is not throwing things.
We are the ones who make it better.
I'll spit on you for $1.
Corey's so big.
Friday.
Are you singing "We Are the World"?
For Africa, not for Haiti. For Africa.
What
I'm
is
a
going
alone.
on?
2 F's or 1 F?
2 for you.
That's what.
There's an extra club. Keep your money in your pocket.
Bravo. I know, because that's all I can give him in this one class, right? Let's be honest, right? I've tried to give him. All right, so this, right? Okay, so it says we've got a bunch of who cares, right? How many parallel line sets do we have here? How many parallel lines do you see?
1.
2 parallel lines. Very good. 1 set, 2 parallel lines. Again, we talked about this. Pants, singular is still pants. Sets of parallel lines is 1, right? So we have 1 set of parallel lines here, and if we just break it down by looking at each individual intersection, I think it's easier to see which ones are actually going to be congruent and which ones are not. Mr. Schloffer, put your money away, please. In your pocket, nowhere else. Okay?
We did.
All right.
We did
No.
5 and 6. That's what we wanted to do.
So, if I cover these up and just look at these 2 intersections, first of all, I want to know, is angle 4 actually going to be congruent to angle 12? They are corresponding because they're the top corners of their intersections respectively, right? But they're only going to be congruent if the 2 parallel lines are being intersected by a transversal. Do we have 2 parallel lines being intersected by a transversal?
So it's a
Yes, we do.
We do.
Right? 2 parallel lines there and there being intersected by a transversal, which means corresponding angles will be congruent. 6 and 14 are also congruent, and again by vertical angles 4 and 6. Yada, 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 right? So, we know those to be true. We also know that 3 and 5 are going to be the same, and 11 and 13 are going to be the same. Cool. Hold it 1 second. Now, what about 2 and 4? Are they going to be congruent? Are they corresponding? Oh, yeah, they are. But are they congruent? Yes or no? Why or why not? Will 2 and 4 be congruent? Somebody. Anybody. Other than Schloffer. Anyone. May. Hi. Didn't see you back there. May. Are 4 and 2 going to be congruent? No, and why not? Yeah, exactly. So S and R are not parallel, which means corresponding angles won't be congruent. So 4 and 2 are not congruent.
Yeah.
So we got a whole different world going on over here. All right, check this out. What about these guys? Do we have 2 parallel lines that are intersected by a transversal? We do. Both of those are parallel, which means these guys will be congruent. So 2 in a different color, because it's not related to 4, is going to be parallel or congruent to 10. Same thing with 8 and 16. Ladies. Raynard, are we all right? I know.
I'm about to have a mental breakdown.
Are you going to be okay, bud?
I'm good.
For real? Autumn, whatever you are, he does not need that right now. Okay? Yikes. Like, I am a jerk. Okay? But, like, that was uncalled for. All right, Brainerd, are you going to be okay now? Okay. All right. 1 and 7 are also congruent. 9 and 15 are also congruent. Questions, comments, concerns other than for my mental well-being? Wonderful. All right. Let's go answer some questions. So it says angle 2. What color is angle 2 in my diagram? Green. Brainerd. Autumn. Wrap it up. So,
start beating myself with that.
no, don't do that.
God, I'm just trying to learn math.
We did do this.
Bring it back.
I'm trying to learn.
Namaste. Bring it back.
Children.
Bring it back.
I'm a tired of this problem.
Angle 2 is 92 degrees. Schloffer, if this is angle 2, 92 degrees, what do we know about angle 10, which is what they're asking us about? Angle 10. It's corresponding, right? They're both top of their intersection, so they're also going to both be 92, and we know that by corresponding angles postulate. So I write that it's 92, and my reasoning is by cap, right?
Hey, guess what?
You know that, right?
Hey, no.
Angle 2, or number 2 is angle 8. Angle 8 is what color? Dykema, what color is angle 8?
We know.
Magenta. Find it. Oh, great.
Green, very good. All right, so we know that angle 2 is 92. What do we know about angle 8 then?
Same thing.
92 as well. Why do we know that?
Vertical angle.
Vertical angles theorem, VAT, V-A-T, very good. Angle 9, what color is angle 9? Rosie.
Angle 9.
Yep.
Sorry.
If my head in the way, I'm sorry, Peter.
It's up.
I thought you were trying to learn
It's
that.
red, very good. So it's red. Now, we don't have any red angles here.
The classroom.
Dykema, zip it. We don't have any angles that are red and have a number attached to them, so we're going to need a couple steps to figure this one out. So who sees how we can figure out what angle 9 would be? Well, first of all, we know that these two are both 92 by cap, right? Corresponding angles, right? And then by linear pair theorem. What does linear pair theorem say? Go for it, Haley. Haley, tell us what it says. Yeah, because they're on a line, they're going to add up to 180. So if this is 92, whatever's left over to make 180 should be angle 9, right? So what we did there is we said we use cap to say this is 92, right? So I'm going to write that down. We use corresponding angles postulate. And then we said by linear pair theorem, these should be supplementary, right? So LPT. Those are the two things we used. If this is 92, how much is left over for angle 9? 88. Now again, you can do that in your head. Altogether it's 80 or 180. Subtract 92. That's kind of hard. Subtract 90. What's 180 minus 90? What's 180 minus 90? Thank you very much, Caden. And then now subtract 2 more to complete it. Now we're down to what? After we subtract 2 more.
Holy cow, it's 88.
88. Holy cow.
Sorry for not as smart as you, Kaden.
88. No, that's not what he meant. Angle 5. What color is angle 5? Brainerd.
What color? I can say orange.
Orange, very good. All right, do we have any orange angles with a number associated with them? We don't have 3.
What? What?
We don't.
3's orange.
13.
I mean, it is, but I meant like, does it have like a angle value? Like this one's 92, right?
What's 1?
Well, it turns out we have more more information in our problem, right? It says angle 12 is 74.
Which means
So how is that going to help us figure out what angle 5 is?
180 minus 74.
So what you're saying is that these angles right here are supplementary, right? So that's by LPT. And you know that 6 and 12 are the same thing, or I should do it this way. I should do LPT with 4 and 5, right? Yeah. And we know that 4 and 12 are the same thing because of what?
Cap.
Yes.
Hard cap.
Corresponding angles, right? So if this is 74, how much is left over for angle 5? 106. In slow-mo, I know these are supplementary, which means they add up to 180, right? So if this is 74, I do 180 minus 74, which is hard to do in our heads, but we can do 180 minus 70. That's 110. I'll subtract 4 more to complete it, right? 106. Number 5 and number 6 are on your own, meaning you're going to do that for homework. And you're saying, wait a minute, what? I thought we didn't. I know, right? I know.
I did those.
Right?
You do.
He knows we don't do our homework, so he's giving us another day.
Tomorrow.
Saturday.
And I never assign homework on Fridays, which is why I assigned it yesterday. 7. Who did 7?
I did.
Figured it out. Tana.
I just.
Wonderful. All right. Andrew, what'd you do?
I did it.
For 7?
Yeah, how'd you figure it out?
First I started at the top.
Okay, so we're talking about this angle. What do you know about it? Keep going.
Yeah. Oh,
Keep going.
I know that since the angle thingy to the right that's unmarked, I don't know what the
No, it's cool. None of this is labeled. Yeah, it's cool. None of this is labeled. It's hard to talk about it.
Out with 3x.
So what he's saying is that these two angles here are going to be corresponding and congruent because there's 2 parallel lines here being cut by a transversal. So this is also 3x, right? And so if that is 3x, what do we know about these two? Say it again.
Linear pair theorem adds up to 180, then it's just algebra.
Cool. So check it out. We've got the red angle added to the blue angle, which is 3x. And they're going to add up to 180 by linear pair theorem, right? They are supplementary. And check it out. Not only is this a true statement, but this is a helpful statement because now we have one equation with one type of variable, and so we can solve for x. Terrible idea in real life, but a great idea in math. What are we going to do?
Add them together.
We're going to get, well, that doesn't complete the joke. We're going to get our x's together, right?
Sorry.
That's okay. What's 9x plus 3x? They're on the same side. Let's get them together. What are they? How many x's? 12 x's.
That's a lot.
That's a lot of x's. Plus 12 equals 180.
Yourself around a little bit.
All right, so now we have a choice. We can either divide everything by 12, which would work in our defense, or we can subtract 12 and then divide later. Get the prenup. Let's subtract. Let's subtract. Good idea, Daikima. All right, so we're going to subtract 12. 180 minus 12 in our heads. Let's do it. We'll do 180 minus 10 first, which is 170. Now subtract 2 more. 168. Very good. Now you look like a genius because you just did that in your head, right? Now we need to do 12. How many times to go into 168? So I'm going to write that over here, just so we have more room. Here's how we're going to do this, okay?
Well, 12 times 12
I-
is 144.
Check it out. So I know 12 times 12 is 144. Now, maybe you don't know that. Maybe you only know that 12 times 10 is what? What's 12 times 10? 120. So 12 times 10 gets us to 120. We're at 120. How much more do we need to go to get to 68? We're at 120. How much more room do we have to get to 68? 48, right? How many times does 12 go into 48? 4 times. So in total, it's going to go into it 14 times. I'll break it down again in slow-mo. Zip it so I can talk, all right? So 12 times 10 is 120, right? Well, that leaves 48 left over that I still got to do, right? I'm at 120. I got 120, right? I got 48 left over to get. So my question is, how many times does 12 go into 48? Well, 12 times 1, 12 times 2, 12 times 3, 12 times 4. That's going to get us 48, okay? It's okay if you don't know, but that's at least a little more manageable, right? 12 times 4 goes into 48. So it was 10 times to get to 120, 4 more times to make it all the way to 168, so 14 times total. So X is 14.
I have a question.
Yes, sir?
Did Schlaffer get on the good doodle board?
You were here for it.
Go.
You were here for it.
Yeah.
Cube.
I was really cute. I'm sorry.
I know, it's all right. You needed to de-stress after that savage beatdown by Autumn. Right.
Yeah, and I didn't deserve.
I know.
Everyone.
No one deserves Autumn. No one deserves Autumn, let's be honest. Right.
Oh,
I meant that in the most positive way possible.
everyone.
Right? No one deserves you.
Actually, not even me, it's my mom.
All right, so check it out. Now we know X is 14. So now we can go back and plug that back into our diagram. What is 3 times 14? Better question. What's 3 times 10? 30. What's 3 times 4? Add them together. 42. Life, the universe, and everything. So that's 42. How can we figure out what this angle is here?
It's the same as the one. Plug it in. It's the same.
So check it out. We know that these two angles have what relationship? What's the relationship?
LPT.
LPT, linear pair theorem, says they add up to 180. So 180 minus 40 is 140. Now subtract 2 more. So this is 138. So what did we learn about 4y minus 10? 4y minus 10 equals 138. Yep. How do you solve a problem like Maria?
You do.
What do we do? Housing gay, what do we do? We're here.
Hearing a neighbor, it makes me miss
I can't hear. What? Add 10 to both sides. We get 4y equals 148. Excellent use of the addition property of equality. Then we're going to divide by 4, which we can do in our heads. What is 100 divided by 4?
25.
25. The only thing funnier than 24. What is 40 divided by 4?
10.
10. So we got 25 from 100. We got 10 from 40. How many times does 4 go into 8?
Twice.
2. So that looks like 37 to me.
Wow.
Break it down. If you can't do a hard problem, make an easier one, right? 4 divided by 100, I can do that. 4 divided by 40, I can do that. 4 divided by 8. Reverse those. Number 8. We have 3 sets of parallel lines and 1 transversal. The transversal is right here. If the lines are parallel, then corresponding angles will be congruent. Thank you. And that is why Schlaffer is a good noodle.
You have smart.
So check it out. This angle right here corresponds with this angle right here. And that angle corresponds with this angle, so they're all congruent. Right? I also know by scissor theorem that these are the same. Cool. Now let's go back through and get the rest of them. So this angle right here corresponds with this angle, which corresponds with this angle, so they're all congruent. And then by scissor theorem, same dumb logic, these are going to be congruent. So 3y equals 2x plus 13. That is a true statement. Do we agree?
Yes.
Okay. However, it's not going to be useful because we have how many variables here? 2 different kinds, right? So it's not going to get us any useful information. However, what do I know about these 2 sets?
They're the same.
The orange and the blue.
One. Oh.
Are they equal to each other?
Yes.
they're supplementary. They're not equal. Check it out. 5y minus 4 is this orange angle right there, which means this orange angle is 5y minus 4. So 5y minus 4 and 3y are supplementary by linear pair theorem, right? Do you see it now if you didn't see it before? These two are supplementary? Wonderful. So what does that mean? They add up to what? Very good. So 5y minus 4 plus 3y equals 180.
Slide that paper up just a tad.
I will. Thank you for telling me.
And then you combine the y's.
Yep, we're going to do a terrible idea in real life, great idea in mathematics. Yep, I'm running out of room. Sorry, guys.
Add 4.
How about that?
280.
I have to make it super big because I can't tell whether you guys are just like really tired or bored or you're just like can't see or what the deal is. Because you guys are having a rough day today.
It's Friday, we want to go home.
Justice, let's go play football.
5y and 3y. Justice, how many y's do we have here?
1. Wait, 2.
How many y's do we have?
Variable.
Yeah, 5 y's and 3 y's. 8 y's, thank you. All right. Next thing we want to do, Carpenter, what are we going to do?
Add 4.
Okay, so we get 8y equals 184. Now we need to divide 184 by 8. We can do this in our heads, I promise. Here we go. There is a way. Not all of you will survive, but there is a way. So here's the deal. Instead of thinking how many times 8 goes in 184, I'm going to think how many times 4 goes into 184, because that's easier for me to do. How many times does 4 go into 100? 25. How many times does 4 go into 80? 20. It's all right. It's all right. Don't worry about it. How many times does 4 go into 4? So in total, 4 goes into 184 46 times. Now, 8 is twice as big as 4, so there's going to be less 8s in that, right? We're going to be less of them, so it's half as much. So instead of 46, it's going to be in there 23 times. And you can check that out. 8 times 20 is 160. 8 times 3 is going to be 24. Add those together, we get 184. So y is 23. How can we find x?
Oh, plug it in.
Yeah, so we know y is 23. So, McKenna.
No.
McKenna, what is 3 times 23?
69.
69! Nice.
Yeah, get up here, big boy.
Nice. Don't say that. Phrasing.
We're live.
And we're live.
For 4 hours.
Which means that 2x plus 13 also equals 69.
Don't say it.
If we subtract 13, we get 56. What's 56 divided by 2? Better question, what's 50 divided by 2? 25. The only thing funnier than 24. What is 6 divided by 2? 3, so 28. Yeah. It's a lot easier to do that, right? And then having to carry ones and all that crap. I can do 50 divided by 2 and 8 divided by 2. Or 6 divided by 2. Yes, you may, just not in here.
No curry range.
Can I use the bathroom?
9, 10, 11. Did you do them?
No.
Wonderful. Now you are. Number 9 on your own. Do it now. And by on your own, I mean do it together, right? Life is not about what you do. It's about who you do it with.
Oh, wait.
No. All right. Sydney, who's going to be your partner? Who are you going to work with? Pick somebody. All right. Rosie, she didn't seem happy about it, but you guys are together now. All right. Dykema, who are you going to work with? Pick somebody.
Do I have to?
Yes, you do.
Can you just like throw them
No.
in here? I don't know who.
Wonderful. You're going to work with Haley. It's not her fault.
All right.
I'm sorry, Haley.
I don't know who.
I'm sorry. That Haley.
Yeah.
Carpenter, who are you working with? Awesome. So here it is.
No. I wasn't here. I don't know.
Yep, but Autumn's going to help you out. It's going to be great.
I know. I think that's supposed to be the other way around.
It's going to be great. McKenna, who are you going to work with?
Myself.
You're going to work with those two, and you're going to help them out. Great job. Brainerd, who are you going to work with? You're going to work with those 3. Great job. Tana, who are you working with? All right, Katie, she chose you. Sorry. You can do better, Tana. You can do better. What?
Wait a minute. Is that racist?
Okay, McKenna's going to help you out.
I don't even have my shoes on right now.
David, you got somebody to work with? Caden, all right. Azingay, who are you working with? Haley. You're going to work with May. Good choice. Haley, who are you working with? Haley, you're working with Laura Lee. Excellent. All right. 2 in the back. Work together. I know, help him out. Okay, compare notes. If you're both done, then you got the easiest group project ever. All right.
Two parallel lines.
Andre, you were the odd person out because Schlaffer is gone. So come up here. Bring a chair. Haley and Dykema actually work together. Explain it to each other. Sydney, don't hate me. Don't hate me, Haley. Yep, he's got it. Okay, so check it out.
I can be louder.
I think you're fine. I think so, just looking at it generally. Alright, so what we're going to do is we're going to draw another parallel line in here. And what that's going to do is going to cut this up. Okay? So now we have a top set of transversals, right, and two parallels, right? And so if you look at it, I think it's easier when I do this. Right? You're good. So check it out. That's, if I gave you this problem, it'd be really easy to do. Right? You probably noticed that, look, parallel lines, therefore corresponding angles are going to be congruent. Those are both 50.
I think I just.
Awesome. So that's part of X, right? Nice line. Nice line. Alright, so now if we do the same thing down here, I'm going to extend this line out. Yeah, so this one's a little bit harder to do, but it's not that bad. So this extended up, right? This angle right here is 100, right? And that's going to correspond with this angle up here, which is kind of nice. But more importantly, we know by vertical those are the same, right? And so if that's 100, you see what I'm saying? Can we figure out the bottom part of X? What's that going to be? Look up here, it might be a little bit easier. Okay? Bottom part of X, I'm talking about that right there. What's that going to be? Can't be. Yeah, it's going to be 80 because they're a linear pair, right? So now you figured out the two little bits of X, right? Put them together. Are you done?
So it's 1/3.
What? Who snagged your paper? Haley, how do we feel?
Hey!
Okay, that works.
We all did It's the same thing.
All right, so start bringing it back in. Hopefully you've been able to explain it to each other. Cube, please. It's like the flag. Can't touch the ground. Here we go. Ball. I'm open. Hit me. I'm open. Thanks, Autumn.
Buy yourself something nice.
It's a dollar. You can't get anything with that.
It's in the candy factory.
Haley, you're the one who ran.
Thank you. The candy factory is so very strict club.
That's my freaking mom. Oh my god.
Hey, Rosie.
What?
Start a petition.
I love it.
All right, bring it back in. So, here's how I went about it, and it should feel very familiar to you because guess what? There's literally this problem right here is the same as the problem we did the other day. Look at this. It's the exact same problem in the same packet.
Yeah, Chief.
The exact same one. The exact same one. And some of you guys knew that, some of you guys didn't. Right? So, here's what we do. First of all, we draw an auxiliary line. Right? And this line, zip it, is parallel to all the others, which allows us to break this down into two different problems, right? The first problem is this, and if I extend this line out, I think you'll see it. If I gave you this, you'd be able to fill out all the angles very easily, right? This angle corresponds to what angle? The bottom one. So they're both going to be 50. Carpenter, zip it please. Thank you. So we've got 50 here and 50 there. That's my corresponding angles postulate. You dig?
Yeah.
Awesome. Now, same dumb crap. This didn't get us X. It just got us part of X, right? We're going to go get that other bit of X, that angle right here. I'll use a different color other than red. we're going to get that angle. And here's how we're going to do it. Same dumb crap. We're just going to cover up this top part. And notice now I've got another set of parallels cut by a transversal. Not as pretty as the last one, I admit. Okay? To figure out that angle, I know that this is 100. And these two are the same, right, by vertical. Now that angle there corresponds to this angle here. So what does that tell you about the green and the blue angles? They're a linear pair. So if the green is 100, sit down. If the green is 100, how much is left over for the blue? What else? If that is 100, how much is left over for the blue? 80. Because they're a linear pair.
Thank you. You're welcome. Beautiful. You're welcome.
Enough.
How is that a
It's all good. So this is 100, Schlaffer, right? 80 left over for the linear pair. You dig? Do you see why that's 100?
Yeah, I think I drew my line on the wrong side.
It's cool. It's cool. So now we know what X is. It's going to be the orange plus the blue, which is going to get us 130. Number 10. Same dumb crap. Go do it. Different numbers. Go do it. I'm going to come around and see what's going on.
I'm saying right here. I'm not doing
Hey, big boy. That's 144. Buy yourself something nice. That's 144.
I'm so sorry.
We get it, kid. Shrimpy.
No way.
Alright, but then that just does not seem like me.
Scissor-theum 62 is the same as
I'm stealing his voice.
Guess.
No, I'm not.
Oh my god.
What's 180 minus 140?
Does he draw his line through the X? Does he draw his line through the X?
Okay. Have the right idea, just wrong number.
Yeah, the classic you. Don't worry about that. Seriously, I didn't make very sense. We talked about it here multiple times. I know you know what you're talking about. It's just be careful with getting the words to match up with what your brain
Oh, I
is.
guess that's what you. So
Yeah.
it's 6. Oh my god, my favorite.
This is one before as well. And then this see that?
Hey, Daniel.
That's funny.
Alright.
Throw it out. Please throw it out. Please throw it out.
How are we doing?
You said you had an idea to
No.
No, yeah.
X equals 90.
No way.
Well, if you
No one wants to hear you talk.
no one wants to hear you talk. Actually, put your money away. Keep it away.
Slaughter's gonna whip out a crisp $1 bill.
I'm gonna shit out of that.
What? We are live.
Buy yourself something nice. For your dad, I'll roll this out. Here was the easier one. Her dad goes
I don't see my dad or my mom, so I don't pay attention.
Sounds like a personal call. Don't want to hear about it.
Oh yeah, it is, except my mom's in the supermarket, so.
That's not true. You say your mom.
Dude, I
How are you
have, I
getting a
haven't,
PlayStation card?
I haven't, okay, sure, I talked to her on the phone.
How are we doing?
98.
I haven't, like, really been at her house in like half a year. I talked to her on the phone so much.
That's really cute.
What? That's how you get it. Actually, wait. I'll send you that here. Jim Bob.
Yeah.
Jim Boy.
No, wait.
You did it. All right. What time did you get on?
All right, number 10. Let's talk about it. Number 10. How did you do it? All right, rest is for homework. I'll see you guys on Monday. I'm thinking that this isn't working either. Yeah.
I did it at home, so I did it different. I'm not allowed to do this.
So I'm used to it. So we both hurt each other. It's okay.
I better get recognized for a noodle.
Oh, because it's a triangle.
Yeah, I did make it like that.
Right, so minus 100. And you know it's minus 100
Costume?
because...
Where'd you get that? By Sadie?
right.
That's such a long time.
So 180 minus 100 gives us 80 left over. Good, so that angle 1 must be 80. Yeah, very good. Okay, and then angle 1 plus angle 2 equals x. Because we talked about that triangle theorem the other day, right? So, the remote interior angles, right? So that's good. Yeah, exactly, right? And so that's going to be 130. Well, that's perfect.
If I do this in the test.
Yes.
I know what it's like to be a
It's a great question. I don't know. It depends. Xavier's not here. Okay. Great question.
For a broken foot, I recommend a full body cast. No. A full body cast and no movement for